Hello, dear students. Today we are going to discuss an important topic of physics, that is dual nature of radiation and matter. In this unit, we are going to discuss about various topics, various physical aspects as well as the concepts that deal with the radiation as well as the dual nature. The very basic and the core concept that we have to study in this topic is, firstly we have to understand the radiation. Then after, we are supposed to know the effect of radiation, emission as well as absorption, how the radiation travels, what are the things that encounters the radiation, and if anything encounters radiation, will be there any absorption, will there be any emission, or will there be with the transference of the radiation. So dear students, we have to understand that radiation has dual nature. To understand this, if we take the basic example of light we know, light we know is an EM wave, that is electromagnetic wave. This you might have studied in the unit before optics, electromagnetic waves. There you must have studied the production of electromagnetic waves, how they are produced, what are the various characteristics and uses of the electromagnetic waves. So dear students, light we know is a form of energy, kind of, that each and every student will be knowing. While analyzing the nature of the light, two theories were proposed. Let me give a little bit overview, then after we will switch to photoelectric emission as well as the work function, the detailing of the same. Light we know, two theories were given. I just want to make you guys to understand the radiation as well as the dual nature of the radiation, how the concept of the dual nature of the radiation was introduced. Light, the first theory for the dual nature was wave theory, uh, which was proposed by Christian Huygens. You have studied the Huygens principle of the wavefronts, and Maxwell. In wave theory of the radiation or light, what was proposed that light is an electromagnetic wave. It does not require any material medium for its propagation. What does this aspect mean, that it does not need any material medium for its propagation? Let me give you a simple example. If right now there will be a blast on the moon, if I will give you the speed of the sound as well as the distance that is from moon to earth, suppose let's take an example. If this is moon, or this is earth, or this is I may say, I may take this as the earth, and if there the distance between these two is known to you, and if I will ask you, if right now I will give you speed, I will give you speed of sound, and I will give you the distance. Why I am giving you these two parameters? Because we know speed is equal to distance divided by time. To calculate time, we can use both the parameters. So dear students, if right now there will be a blast on the moon, when we will be able to hear that? Many students will think, sir, firstly we will calculate the distance, we will use same unitary method in order to change the units, if that is in time and all that, by following the SI units. So many students will calculate time as distance divided by speed. They will try to calculate it. But dear students, understand this thing. I talked about the blast, and I talked about the sound. That when will be I able to hear that sound? I will never ever be able to hear that sound. Reason is simple, because there is vacuum. Sound is also a form of energy. Just to make you guys understand the light as a form of energy, material medium, I am just for its propagation, just making you analyze that thing. Sound we know is a form of energy, as well as light is also the form of energy. if right now there will be blast on the moon, we will never be able to hear that, because the sound also is a form of energy, that but that needs material medium for its propagation. As we know, uh, near to moon there is vacuum. By just to understand in a simplest manner, vacuum, you understand, no medium, neither air, neither plasma, neither anything, no medium. So this means, as if sound needs material medium for its propagation, as there is no medium, then how come the sound of the blast from the moon will reach to earth? Never ever. But you can ask the simple question, sir, this is moon over here, that is very far away, but sun, if we will take this as moon and this as earth and this as sun, the distance between sun and moon and our earth, the distance between moon and earth is comparatively very less from the distance that is between sun and the earth. But the speed of light, or I can say the radiation from the sun, reaches to us in 8 minutes and 10 seconds. We also write minutes and second like this, 8 minutes and 10 seconds. Okay, so now the question arises, sir, as here was no vacuum, we were not able to hear the sound. How come the speed of how come we can see this sunlight which is coming from that very much far distance? The simple reason is that light is that type of electromagnetic wave which does not need any material medium for its propagation. No need of material medium for propagation. So the basic concept for the wave theory is clear to you guys. So the first thing was, the wave theory suggests that light is an electromagnetic wave. I need not to tell you about the electromagnetic wave. I just want to you guys to understand the concept of material medium. So the light as an electromagnetic wave does not need any material medium for its propagation. So that is the reason sun being that much far away from the earth, we can see the sun rays coming to us, because the light does not need any material medium. That was the very first theory, which suggested that radiation as a wave, that is the main climax or the crux of this theory. As we had to study dual nature of radiation, we need not study the light wave optics or ray optics that you have already studied. That is, this suggests that light is a radiation which is a wave. That is suggesting that light or radiation is a wave. Now the second theory that was given by Einstein, that is particle theory, or you may say electromagnetic theory, in which what was inferred that the light consists of packets of energy, or bundles of energy, what we call as quanta of energy, or I can say simply photons. I will not discuss about the quanta, quantum, packets, bundles, because I had to deal with some other topic. So what suggested Einstein suggested that light is composed of packets of energy or bundles of energy like this, which we call as photons. These photons have energy of h nu. In this particle, in this theory, he suggested that these photons possess some or the other way the nature of the particles, because these are responsible for photoelectric effect. Photoelectric effect can only and only be caused by that substance or that thing which has particle nature. So interference, refraction, diffraction, all those were conduct uh, light causes reflection. That is the property of wave. Light causes refraction. That is the property of wave. Light causes interference. That is a property of wave. So we can say light is wave nature. Light has wave nature, to be very specific. Light causes photoelectric effect. But photoelectric effect is caused by particle. Anything that has particle nature, that causes photoelectric effect, because it has to knock down the electrons. Light, while studying again, light cause Compton effect. That's also depicts the particle nature. So if light can cause both the phenomena which are encountered by a wave, so I can say that light has a dual nature. So this dual nature is to be studied here because we have to deal with the photoelectric emission as well as the photoelectric effect. So dear students, for the numerical portion of view, you had to remember the value of the h, that is 6.64. While dealing with the numericals, we will tell you each and everything, and we had to deal with the frequency, and we can correlate E is equal to h nu and E is equal to mc square, E is equal to mc square, and we can deal with the m naught, that's the rest mass, and we can correlate as per the relativistic theory. So dear students, just to sum up the climax of all the things we have understood, that light, wave theory, particle theory, as well as the critical dimensions, that sound needs material medium for its propagation, whereas light does not need. So that we can say that I was just justifying that wave theory, that's electromagnetic radiation. Now, dear students, we have to understand that the topic which we are supposed to discuss today is photoelectric effect. So I can write photoelectric effect. So what is photoelectric effect? Dear students, first understand, by photo we mean photon, by photon we mean light. Here by photo we do not mean, or it does not infer image, picture, diagram, as even though they have the difference. There's a difference between picture, image, and figure and diagram. By photoelectric effect we mean electric effect or anything effect, assuming that you don't know still, that there is something which is caused by light, whatsoever that will be. We are going to discuss that further. So photoelectric effect, before studying photoelectric effect, or I may just tell you the definition so that we can go ahead. It is the emission of electrons. It is the emission of electrons when a light of suitable frequency radiation falls on any metal surface. Just assuming that you just have to remember the concept when I will discuss each and everything, that's effect of intensity, effect of frequency, each and everything will be discussed via graphs as well as via uh, image as well as examples. So I just told you the emission of electron from a metal surface. Emission of electron from metal surface, dear students. So dear students, you will say, sir, assuming this as the metal, will there be emission of electrons of its own from it? If I will place a gold leaf electroscope over here, or if I will place galvanometer or microammeter over here, will there be any deflection in this, or will be the emission of electron, assuming as even though it is metal, assuming it as metal, and will the electrons emit from its surface of its own? No. Then the thing we have to understand, for photoelectric effect to occur, or we just have to make the photoelectric effect happen, what we have to do is that we have to make the electrons to be emitted from the surface, metallic surfaces. Now, you know, you have studied chemistry, you have studied physics, that while dealing with the structure of metal or structure of atom, we know atom is having three fundamental particles. Three fundamental particles, do remember, electron, proton, neutron, are not called as subatomic particles. They are fundamental particles of an atom. Fundamental particles. If you will be asked what are the fundamental particles, you have to remember that three fundamental particles are electron, proton, and neutron. You know, proton and neutron collectively they lie in the nucleus and they are called as nucleons. And there are many other, just giving you additional information, there are many subatomic particles in an atom, like gluons, hydrons, mesons. Meson you had to add up as per the Yukawas. Meson theory, that is very important theory that gives you the answer even though hydrogen is not having the neutron. How is it stable without neutron? You might be knowing that we do have three mesons, positive, negative, and neutral meson. How it correlates, negative meson relates with the proton of the atom of hydrogen and gives stability to that atom. That is very different topic. Just adding up your in your knowledge. So this is meson, gluon, hadron, pion, boson, graviton, and many other substances. So that was your additional information for photoelectric effect. We have to deal that these electrons, we know they lie in the nucleus. The electrons, sorry, protons and neutrons lie in the nucleus, and electrons are somewhere there in the shells. I need not to discuss the chemical aspect, that is what is the difference between shell, subshell, orbit, orbital, that you will study or you might have studied in the chemistry. I will not discuss, assuming that the electrons are in the circular shells. So this electron is having negative charge, minus 1.6 into 10 raised power minus 19. This proton and neutron, which we collectively called as nucleons, they lie within the nucleus of the atom. They do, nucleus do have positive charge only because of protons, neutron being the neutral charge. Why? What determines proton positive? As I told you, as you might be knowing that quarks, up, up, down, and up, down, down. For your additional information, they determine proton, and I can prove that, but time will not permit me for the same. So nucleus being the positively charged, it will attract electron. It will attract, for obvious, when there are two different charge, electrostatic coulombic force of attraction will be there. It will try to attract the electron towards the nucleus. So there will be atom, there will be neutron, there will be electron, there will be proton. Nucleus will try to drag electron towards itself, so that, which means that electron will not get emitted of its own from its metallic surface. That means we have to apply external agent. You might be knowing the catalyst in chemistry, that if the reaction is not accelerating, we apply a positive catalyst over there. Here we have to add a catalyst kind of reagent, kind of an external agent. That external agent can be in the form of, do remember, can be in the form of energy or in the form of frequency, or that can be in the form of electrostatic potential also, that can be in the form of temperature also. I may write for your additional information, that can be electrostatic potential, or that may be temperature also. We need not to discuss the field emission. When the emission is because of electrostatic potential, very strong electrostatic potential is supposed to be used there, that we call as field emission, that is not to be discussed. And if we use the temperature, that is what we call as thermionic emission. Okay, dear students, so okay, I was discussing this. Let me change the color. Okay, this electron will be dragged towards the nucleus, but this electron is supposed to be emitted from the nucleus, for obvious. That means we have to apply some kind of energy. Firstly, taking the concept of the energy, that means we have to apply some kind of energy which will drag out this electron, which will drain out this, which will emit this electron from the metallic surface. The energy, the minimum energy which is to be applied to the electron so that it will be drained out from the metal, is known as, I can write for you, work function, and was the symbolic representation, that is phi. So what is work function? Sorry. So this is metallic surface. I have to apply a sufficient amount of energy which will drain out this electron from its metallic surface. When there will be draining of the metallic surface, electrons from the metallic surface, I can say this is emission, because it is getting emitted from the metallic surface. Okay, so that means I have to apply some energy on this. The energy for this metal is known as work function. So you understood the definition of the work function, so I can write the literal definition of the work function. it is the work function. The definition for the work function is the minimum energy to be applied so that so that just a second, emission of electrons can be done. I have told you the symbolic representation is 5. Now, dear students, if this is metal X and this is metal Y, assuming this, taking this as the example, this is metal X and this is metal Y. So I can write, if this is metal X and this is metal Y, is it like that I have to apply the same amount of energy to drain out electron for both X and Y? No. There are three factors on which actually this work function depends. I will discuss only one right now. We will discuss both as. So the first thing is that in chemistry, you know what we call as electropositive atom. What is electropositive atom? That atom which has tendency, going to the literal meaning, just to revise up, there are some few technical definitions too. That electropositive atom or electropositive substance is though that substance which does not have that much nuclear pull, so that electrons will remain within the shell. That means it can lose electrons very fast, or you need to not apply minimum maximum energy for the same. Another is electronegative, that is which has a very strong pull towards the, as you know, fluorine is the most electronegative, then oxygen, then nitrogen. So fluorine is most electronegative. That means if I have to drain out electrons from the fluorine, it will be too difficult for me to drain out the electron. But here we have to discuss only metals. So if a metal is very electropositive, very electropositive, like in case of cesium, and some metal that is platinum, this is cesium. Okay, this cesium is very electropositive, and this platinum is not that much electropositive. Electropositive means that it does not have that much tendency that it can hold the electrons. When I will apply some energy over it, it will easily lose the electrons. These electrons will be lost very early on some minimum energy. Suppose if I will give it 2 electron volt, I will let you know why I am using electron volt, why I am not using joules somewhere. Just to give example, we will go through the joules, kilojoules, each and everything, just to make an example understand. Here I have to use only 2 electron volt. If same 2 electron volt will be used for the platinum, dear students, this being electronegative than cesium, it will not lose electrons at 2 electron volt. We need to apply more energy. That means if assuming I will have to apply 10 electron volts, so that electron will get drained from this platinum. Okay, dear students. So the first thing we have to understand that work function is the function of the nature of the material, or it depends upon the material. It varies from the material to material. Now, is it only factor? No. Another factor is temperature. Let's understand that. Now, I will take cesium and I will take cesium again. You will be saying, sir, you are taking both the cesiums again. So what thing will matter here, so that we have to apply a different work function over here. Cesium, if this cesium is at, assuming that 100 degrees centigrade or 100 degrees Celsius, this is at, even though this is very high temperature for it, and this is at 20 degrees centigrade or degrees Celsius. Okay, let me change the color. Okay, if I will apply some energy over here, and if I will apply some energy on this cesium particle, both are cesiums, right? You have to understand this, but they are at different temperature. Here, as we know, the temperature is very high. We need not to apply that much work function over here. In ideal condition at room temperature, if suppose cesium is to be given 2.7 electron volt, and now here we are supposed to assuming taking ideal conditions, we are just for the sake of argument taking let's say that we have to apply only 1 electron volt over here, because the temperature has already risen or raised the kinetic energy of the electrons will be easily knocked or emitted from the metallic surface. But here, if under normal conditions we have to apply this, and the temperature of the cesium particle or atom is very less than this room temperature, because this is measured at generally at room temperature, so that means we have to apply 3 electron volt. So the second parameter on which work function depends is, first was nature of material or type of material or type of metal. I may say nature of metal, whether electropositive or negative. Second is the temperature. Okay, dear students, is this clear to you? So one more thing is that is impurity. I will not discuss that over here, because in semiconductors you will first study what is the effect of the impurity, whether that is when the intrinsic semiconductor is made extrinsic by either p-type, n-type, and pentavalent is doped into tetravalent, and tetravalent is doped into trivalent, or tetravalent is doped into pentavalent. You will study over there with your students. I will make you understand here very clear. Now you understood. Firstly, we were about to discuss that is in photoelectric emission, that is we had to do emission of electrons. Now you understood that to emit electrons, firstly we had to understand the nature of the material, whether it is electropositive, whether it's negative, or let's take this electropositive. Then we have to understand what is the temperature of material. For this, we have to understand, I told you that emission of electron can be either done by increasing the temperature, or it can be done via photons. Sorry, it can be done via photons, or it can be done applying a suitable potential difference. I can use the better words, potential difference. When it is emission of electron because of temperature, we call it thermionic emission. Thermionic emission. When it is because of photons, we call it as photoelectric emission. The current due to thermionic emission is known as thermal current. Here we call it as photoelectric current, and because of this is what we call as field emission. Okay, dear students. The emission can be via some other means too, by making them collide. Collisions you can do also. Now we have to study photoelectric emission. Photoelectric effect. So dear students, it is knocking of electron, emission of electron from a metallic surface by photons. Simple definition. Now it might be very simple for you, that is knocking of electron by photons. That's what is called the photoelectric effect.